Hey mathematicians, Caitlin Henderson here with another vocabulary video. This time we are going to be working in Unit 7, Lesson 5, discussing coordinate proofs. Last unit we talked about proofs, and those are more formal proofs. This time we're using the knowledge that we have gained so far to prove different aspects of shapes in coordinate geometry. The first thing we need to understand when trying to prove different aspects of coordinate geometry are shapes and the part of shapes. So first and foremost, there are three types of triangles that we are going to be discussing. You're going to be asked to identify if a triangle is equilateral, isosceles, or scalene. An equilateral triangle has lengths that are sides that are all equal to each other. So this right here is our example of an equilateral triangle. You see that all three sides have a length of 3. Up next, we have isosceles triangles. Isosceles triangles have 2 sides that are equal. And we have this example right here. We can see that we have 2 sides that have 2.24 in length, and then our base here is 2. So this is, in fact, an isosceles triangle. The third type of triangle is a scalene triangle, and scalene triangles have sides that are all different, so none of the sides are equal to each other, like you can see in this example. We are going to just kind of briefly talk about circles, and so I want to make sure you understand the different parts of a circle, okay? So we have a little circle that's right here. And I have 2 points that are labeled here. We have this center point here and a point that's on the circle itself. This distance between these 2 points is called the radius. Okay, radius. It's our vocabulary right here. So it's the distance from the center of the circle to the outside line, basically our circumference, right? The line that creates our circle. That is our radius, okay? We want to make sure we understand this, what this distance means here, because we are going to try to prove that points lie on a circle in the actual lesson video. Now, lines. What do we know about lines? We know that parallel lines are 2 lines that never intersect. So we have these 2 lines right here, right, that are parallel to each other. They never intersect, they never cross, and they have the same slope. Remember that, they have the same slope. Perpendicular lines are lines that cross at a 90-degree angle. So we actually have 2 sets of perpendicular lines because we have a transversal here. If you remember what a transversal is from our last unit, it's just a line that cuts more than one line. And we have parallel lines here. Every single angle here cut by our transversal, because it's a perpendicular line, these are all 90-degree angles, okay? The other thing to remember is that their slope is the opposite reciprocal. We'll talk about that in the main lesson, but just keep that in mind, that if we were asked to find the slope of a line that was parallel and a line that was perpendicular, one is going to have the same slope and the other is going to have the opposite reciprocal. I already kind of talked about 90-degree angles, but just remember the other name of a 90-degree angle is a right angle. And all right angles are congruent, is something we talked about last unit, but congruent just means same shape, same size. Okay, I've said that so much. For our last little bit of information that we need to know, we need to discuss here slopes of lines and the parts of the equation itself. So on the last slide, I was saying slopes are the same. Slopes are opposite reciprocals. What is the slope? The slope is the steepness of a line. Okay, we can calculate the slope of a line by doing our rise over our run, and we will discuss that in our lesson video, right? But it's just how steep is this line? And remember, we always read lines from left to right. So if I were to be moving left to right, I'm going uphill with this line, so it's a positive slope, okay? And if you see, actually, our equation here is x plus 2, so that actually means x is equal to 1x, so our slope, m, is actually equal to 1 in this line right here. So that's how steep it's going. And that just means it's rising 1, it's running 1. It's rising 1, it's running 1. Y-intercepts, okay? We have let me talk about this first. We have this a slope-intercept form of a line, y equals mx plus b. That is the equation of a line in slope-intercept form. That's the equation that we have right here, y equals mx plus b. M is our slope, so here we said that it's 1. This b here is our y-intercept. It is where our line is crossing the y-axis. So you can see here that we are crossing the y-axis at the point 2, so our slope, or our b, is, or excuse me, not our slope, our y-intercept, or our b, is equal to 2. Okay, and just one more friendly reminder, a coordinate is a specific location on the graph. So this coordinate of our actual y-intercept here is when x is equal to 0 and y is equal to 2. Remember, it's always in the form xy, okay, always in the form. And so we look at where would our point cross the x-axis and where does or would our point cross in the y-axis to get that coordinate location. Okay, guys, that is it for the vocabulary words. Like always, please reach out if you have any questions, and until next time.